Hi, I'm Bob. Here today to talk about the quick update on the DM32. And because we are limited to 30 minutes per talk, I've scheduled a 15-minute discussion. I did a talk on the DM32 last year before the product had shipped with a fairly high-level overview, mostly focused on the new platform and not as much on the details of the implementation of the calculator itself, though the basics of it were in testing already by then. And some of the stuff I'm going to show you today is out there in beta now, and some of it is not. So I'm going to start with maybe a review. Just to go through it, I'm not going to read you these numbers and all that because I honestly can't remember them and can almost not even read it. But it's the new STM, the new platform. We discussed it. The numbers are all there. You can read it. More, better, faster. Much faster in a lot of ways. One of the key differences, it's a USB-C connector, even though it's USB 2, but just, there's no right side wrong kind of thing. So it's just a lot easier. When you're flashing a device 3 times a day, just having that kind of connector, and little magnetic connectors you don't even have to plug in, or even better. The DM platform uses the famous Sharp screen, the 400 by 240 screen that everyone knows well. And the same keyboard, physically, the same keyboard of the improved generation that appeared in the DM42 and the 41X. The top row of keys is blank, and those are generally called, we generally call them function keys, and those take on different roles for different functions in the software, accessing the enhancements over the core DM32 functionality. One of the key enhancements over the core DM32 is the floating point library from Intel, used also on the 41X and the 42. And the show, which you see demoed there with Pi, traditionally the 32S2 shows you whatever is in X while you hold it down, but you used to be able to basically read the digits. With 34 digits, no one's remembering those 34 digits. So reality just kind of evolved to it has to stay on. Not only that, but now you can capture the screen of it. So if you're collecting data, you don't want to write it down or whatever, you can just capture a screen and then get that later. The RAM is dramatically, there's probably a number there, right? Yeah, 680 times larger than the RAM available on the 32S2. And last year we were looking forward at, with that much more RAM and the 32 memory space that was so limited with just a limited number of globals, you just couldn't utilize it effectively. So we're going to talk about some of the ways that problem's been solved. Recent enhancements that have come in the platform, well, let me back up. A lot of very visual enhancements have shown up in the last 3-4 months probably. Before that, a lot of enhancements were taking place, I would say, under the hood. Due to a lot of people's sweat and tears, primarily, we have to congratulate Joe Horn for finding some of the most obscure, which is his ilk, to find some of the most obscure bugs. And David likes to say, Joe finds really good bugs that aren't in the area that he finds them. It's always, it looks like it's here, but it's really over here doing something, which are really good bugs to find because you don't know, that kind of thing. So there have been a whole bunch of things that have improved related to stability, related to accuracy, the algorithms involved in the solver and in integration. So the engine under the hood, let me back up. Some people haven't gathered what I guess I and Michael and David thought was obvious, possibly never said though, which was the idea was to release the core 32S2 so that people who know that or want to learn that would start doing the math things on it that might eventually find bugs. While that is playing out as a beta, if you will, then the development would shift to some of the enhancements and user interface and things of that nature. So that's why it came out initially looking and acting very much like a 32S2 with, for example, a 1-line display on a 4-line screen. What the heck are people, what are they thinking? And the answer was to just learn the platform and start using applications to drive out some of the math and precision issues. But recently, some of the enhancements have stepped up to that. The the traditional four-line stack. And one small thing I thought of actually on the drive up here was all of my screenshots show one font. Actually, there are five, Joe? Five? Four with the, well, four, at least four, but there's a variation with you don't have dots and there's zero and stuff. So there's a bunch of different fonts. Only this one looks correct. But opinions vary wildly on this subject, which is why there's five of them. But I realized I should have used different fonts on my screens, but I didn't. I just used the correct one. So these screens show the things that functionally these views are no different than they were in the 32S2, but they feel radically different because in the 32S2 you had a catalog of memory and you had the programs or the variables, global variables, the list of equations. Obviously the editor, a multi-line editor, that one's an obvious one because we've seen that already in the 42 and the 41. But these lists make it feel very different. What you can do there is no different than what you could do. In fact, it's by definition identical to what you can do, but it looks and feels different. And essentially each of the full screen lists behave the same way. They scroll up, they scroll down, they wrap around, and there's a cursor for the action item, the one that nominally was in the one-line display in the 32S2 for you to execute or delete or whatever the thing is you're going to do with that line. Storage. This has been quite recent, and this is an area where there's been dramatic change. The 32S2 has 33 global registers, A through Z, the statistic registers, and the indirect register. So that's sort of the starting plane of what you can store. We recently added 2 new sets of 900 registers each called extended registers, and the extended registers are within each state file or each state. And we'll talk about that in a minute. And they are numbered 100 through 999. Now you can't recall 100. They all use the indirect register. So you store 100 in the indirect register and then you recall indirect I, so to speak, as a pointer to them. So you have 900 registers there in each state file. In addition to that, the global registers is another 900 registers that are global to all the state files in the machine. In other words, they're not stored in each state file. They're universal. They're available to any state file in the machine. And why is that? Why would you have them be out there and so forth is an obvious question. So the memory has increased more than 50 times. I knew there was a number there somewhere. So this is kind of a review of the state file. Fundamentally, the concept is no different than the state file introduced on the DM42, and differently but similarly on the 41X. The idea is it is one file that stores all the stuff that's in your machine, all your programs, all your variables, all your settings, all your equations, everything that is unique to the state of that machine, hence the name. State files can be copied into the DM32 using just drag and drop from the USB disk. You just hit a shift option 1-4, I think, if I remember, and then it becomes a disk drive. Pardon me. And off the root of the storage folder, there's a /states folder. Not surprisingly, that holds your state files. The state files are text-based. There's a example one, a very simple one there shown on the right. The idea being you don't need raw files and you don't need a converter that converts the binary format and so forth with all of the issues. And to this crowd, it's a little confusing and unexpected, but there are people who just don't get those kind of things at all. Like I just don't, even though it's not operationally difficult, it's conceptually challenging to them. So the idea was if we switch to a text file, assuming you want to do this at all, I mean, there's nothing simpler than a text file variation of what it is. You don't need a conversion tool. You don't need anything except text. Now, there's a little bit of challenge in that because there are some non-ASCII characters in there, and those are basically created conceptually the same way it was done in a 48, where they're, what was the term used for the 48? The slashed, there was a term that came for that, but basically the slashed characters, you know, like an escape sequence for the coding of them, and that's all documented in the manual. But what else is there to say? So that is a state file, and it's just, you know, Bob's file .d32, and I open up a text editor and make it, and then copy it, drag it over into the machine, and then I use, probably this does it, yay. And here you got an open file, and you know, load a state, and you got a file list, and you move it down, and you pick one, and these are just example ones that were in the machine when I grabbed this thing, and you just open the state file, and you can see I have, what, 10 of them or whatever. So each one is essentially a complete calculator of stuff that's there, which is super handy when you're testing, because if you get some bug that is difficult to report, difficult to understand, we just have the user just save it in a state file and send the state file, and it can be loaded up and copied. You don't need, in some cases, there are things that you never really think about as challenges in trying to get a bug report. People who don't speak English, barely at all. For some people, that's not a problem. For me, that's a problem, because if I'm getting a bug report and it's barely English, at least the state file makes it clear exactly what they're working with. You'd be surprised how many people report a bug that says, it's wrong, it should be getting 14, and it's not. What's wrong with the calculator? You know, we need more than that, sorry. So this is also, I won't say it was, I won't say it came about as a tool for collecting data, but it's darn good for doing that. You can go back and forth between this calculator and that. Oh, I'm sorry. This is one I'm going to pass around the room. I'll skip Richard for the moment. It has a soft case around it. Oh, my bad. It has a soft case around it made by Dan Simpson, who also contributed gifts for the prize table. I omitted him this morning when I was talking about it. So just, I'll hand that around for people that haven't seen one. That one has some test software in it that the explorative and nimble ones will discover things that they haven't seen in the public release yet. When we break for dinner, whoever has it, when we go, just holler to me so I can grab that back. Trust, yeah. It's a trust-based thing, isn't it? You can, just like you would pick up this calculator and that one, you can do that with state files. You basically just go open a new state file, grab it, and then swap. And so you can be in checking bugs or whatever, or if I may have a program for doing beam calculations, but I also have to deal with a budget kind of thing. And I just have one whole thing set up for all my financial stuff and another for that. And I just switch calculators, just like I might pick up a 41 or a 17 to do that. Now they're just states. One of the enhancements that has come out 2 releases ago is the concept of having multiple states available loaded simultaneously in RAM. So I can open up, as you see over here, oops, wrong button. These 3, you know, this one's obviously the one I'm in, so to speak, or when I came to this dialog, you just press F4 and it brings you to this, and I can now open, you know, I can load one and open and have multiple in memory, which I can swap even faster than the 8 or 10 keystrokes by doing file, open this file, that file, pick another file. This lets me toggle back and forth between the states in about 5 seconds. You can just go back and forth between multiple states. So it's even faster to go back and forth between them. Now, also remember, the global variables are global. They're available to all states. So I can collect data and put it into the global variables. Also the stack is also available to all states. So if I swap between states, everything I loaded up into those variables and the stack is available. So depending on your application, you would either pass data between them on the stack, or you might pass an index to the registers where you put all your data on the stack. So you can just pop back and forth between the states and very quickly go back and forth between basically very different environments. I think I said everything there. Oh, there's the standard things. So I can load one and save it and get info on it and delete and so forth. You're limited by RAM. I would imagine if anyone in the room has figured out how many states have you been able to load simultaneously?
I can't figure that out because even when you fill program memory so that it says memory full, you can still load more states. So I don't understand it.
See what I mean? I believe that there is an undocumented reserve that's there. In other words, when you're full, you're not full, so that you can recover from what's there, kind of thing. But I don't know I never got an answer to how much is there. Probably won't, because that's why there's bumpers there, right? So that you won't, go off the edge. This is not available yet. This is coming between now and the end of the year, and I can't say exactly how soon. This lets me call a routine in a state that I'm not in. So I can have my current routine loaded, my current state loaded, which is limited to 26 global variables, A through Z. But I have another state that's loaded that also has possibilities of A through Z, and another state with possibilities of A through Z. So why would one want those multiple states loaded? This is the ultimate reason, and this is really where it's going. You can essentially create a state file, which is, you don't have to do it this way, but in my mind what it leads to is create a state file full of subroutines that are just basically library routines that you make available to all the other application programs that you want to use. So I can make, for example, a curve fitting application, and if I have a linear curve fit that I want, that might be called L. As you can see here, oops, wrong button again. As you can see here, normally you would just say execute L, right? This is going to be different. You're going to say execute L, and it will pop up and basically say L in which state. And I pick the cfit file, and then the instruction on the line changes to execute L : cfit. So I'm seeing on that statement line which routine I'm calling in which state file. And things obviously have to be done to verify, is the state file online and is it there and so forth. And so there's some stuff that has to be built around that. But the idea is to keep the programming model the same as it is in the 32S2. Everybody understands execute G. It's just execute that G or that G and so forth, extending what you can do, again, limited by memory. There was earlier thoughts of, instead of just having A through Z, maybe we have lowercase a through Z, but it's just not it doesn't scale as well that way. So, and full credit for this concept goes completely to David, who is just really off the charts when it comes to this kind of stuff, because we talked about a lot of ideas, all bad, about how to do it, because they were simple additions like lowercase a and things like that, or 0, 1, like on the 41 and all that. This clearly is kind of a step into a Twilight Zone sort of, yeah, I never thought about doing that. Another new feature coming is debug view. And I don't call it mode because functionally it's really not much different than debug that's there today. You can single step, right? You can just single step your program, and if you take a step, then you can look at variables and see what's there and then go back and single step again. Now, when you go into debug view, you're going to press F2 and you're going to see it change to this. The top two Z and T registers change to one line showing you the next instruction, the instruction about to be executed when you press single step. And this is a watch variable. For whatever thing I'm doing here, I've decided I want to watch the results of B. So I don't have to go look at B when I stop. I can just because it may not be the thing I want to see may not be on the stack. So it's not a matter of simply stopping the program and then looking. So I just decided as I'm running this, I want to just have B show up. Down here, you'll notice the same thing, except there is the next instruction and the next 3 variables. I'm sorry, not the next 3, but 3 variables that I've chosen to watch. And for those under 40, you can also add another line with these tiny characters, and they are small, and there will be challenged eyes with this, but you can watch up to 7 variables plus your next instruction. So in my mind, there's talk about, well, can't we do 3 lines worth of that? And if you're trying to watch 12 variables as you're debugging a program, the 32 is probably not the platform you should be using. You really should be using, I don't know, a VAX or something. So the final tuning of this is if we've made a library in another file, and I figured all that stuff out, and I'm going to use them in all my new programs, when I'm debugging my new program, I don't want to waste time single-stepping through a library routine. I wrote it, I built it. The whole reason I put it there was because I just want to use it. So now we'll be able to terminology varies depending on projects and things, but you can step over a routine. So if I'm going to execute G, I don't want a single step, 94 steps in routine G. I just single step over, and the results of the G subroutine is treated as 1 step. So then I can then go look at them. And you have the choice to single step or step over in real time, whichever button you push kind of thing. So it really kind of solves that problem of if you're going to have all this power, you need to still be able to use it reasonably effectively without having to get tied down and all that. Status of the 32 right now, it's been available for purchase, and even though it's in beta, the hardware is final. It is the new platform and so forth, and the hardware and the bezel and all those sorts of things are final. The software comes out, so far it's been about monthly. Some of these new chunks are big, so it may be not quite monthly as we head towards the end of the year. There's some new support resources that are very new things that are very helpful, particularly for people that are trying to learn the product. Online manual, a guy named Amy Enstein has joined SwissMicros, and he's a graphic artist and a documentation specialist and a font guy. And you can see the more refined graphics and fonts and these sorts of things. And if you've looked at the online manual for the 32, it's unlike DM42, which is this is what's unique in the calculator, but there's that manual from HP that explains all the calculator stuff. And the 41X, which is similar for that reason. This manual is far more comprehensive. It tries to take on the functions, what are the functions, how do I use it, how do I write a program, how does it all work, to be a more comprehensive standalone manual. In addition, here is a link that has, not all yet, but eventually will have essentially all of the sample programs in the manual already poked in, mostly thanks to Gene, he gets credit for that. Essentially all of the examples in the user manual in state files. You can just grab the state file, download it, and like what's a good one? The stats is, I don't have the list here. The stats or anyhow, there's a variety of good examples, not trite examples, but reasonably good ones. And if you want to do it, of course, what do? You look at it and go, yeah, this is interesting. How do I key it in? No, I'll get a beer. I'm not gonna key it in. But now all you got to do is like 3 clicks and you have the file. And I mentioned the files. Some of the characters for some of the instructions are slashed characters, and if you use it for a while, you can figure them out pretty quick. But if you don't use it, you won't. They also let you just kind of click another button and you can see a text representative, so you can do a print, just print it to have a code listing sort of thing. And all that's like within 2 or 3 clicks from the website. Right now it has much of the user manual. It will go on to add the 32S Engineering Applications Manual. Even though that was written for the S, it applies to the S2. Yep.
I just want to mention also that not only are loading state files real easy, but doing the firmware updates is incredibly simple too. You just dump the firmware file.
Yeah, so for people who haven't done it, when the firmware updates come out, basically there's a file that you download, you connect the device to act as a disk drive, you drag that file to the root of the device, disconnect, and when it resets, it loads the firmware automatically. Actually, that's the slower way of doing it than using the tool made for doing it, but it can't be simpler than that. You know, it just cannot be simpler than drag a file over. But good point, thank you.
Bob,
Yep.
you mentioned the state file with the global and extended routine.
Oh, I'm sorry, yes, thank you. One of the obvious implications, once you think about it a little bit, is you have 900 registers in each state file. You have 900 registers that are global, that is kind of your scratch work area, if you will. An obvious thing that anyone who wants to do this is, I need a simple way to copy this range of 40 from here to here, you know, from my globals to there, then work on them and then do back. Gene has written up a state file of utility functions for doing these kinds of things, moving them over, sorting them, you know, like for people who've never used indirect registers, and for a product like the 32S2, that's most of them that haven't used the indirect registers. It's kind of a cookbook way. It's not out there yet because the features to utilize it aren't out there yet, but it will be coming out. Thank you, almost forgot. I wanted to thank some people. Obviously Michael for his leadership. David for putting up with me. No small feat. It needs to be experienced to be appreciated. Amy for really giving us a big step into some better manuals, graphics, and so forth. Joe, Gene, Jake, Vladek, and Logan have been doing testing and testing and testing. Joe deserves his own line for doing sometimes very humorous testing. Some of the bug reports that come in, and it's an interesting, if you've been involved in bug reports and dealing with bug reports, people will find a bug that they're convinced is a bug and report it, and regardless of if it's really a bug or really a problem, they'll fall on their sword to make sure that that bug gets fixed. These are much more interesting, you know, it's just like, you know, like discussions kind of like, oh, this is unexpected. I think it's a bug, is it? And explanation, you know, tech talk, tech talk, tech talk. So it probably will stay that way. What do you think? Yep, makes sense to me. I just want to make sure, you know, just checking, you know, sort of thing. But there was also some very funny ones. I had one I was going to quote, but anyhow, it's fun. It's a fun process to do it. And it's a very different process when it's approached that way. It's approached like a discussion, not like a criticism kind of thing. And it's been a fun process. Gene for doing lots of state files and also for putting up with me. HP obviously gets credit for giving us the vision and where we're going with a lot of this stuff. And I have no idea if I'm even close to running over or not, but I'm going to move on to questions. Oh my God, and we're going to dinner next and there are questions? Namir.
Is there any software emulator or they don't want to do that to discourage?
No, they sell calculators. Actually, I'll be more direct. There is emulation not ready for the room, but when the product was being developed, so here's an example of the sophistication of the stuff that David does. To validate a bug to some extent being defined as different results than you get on the 32S2, notwithstanding the extra precision, but you know, one calibration of is it a bug is, does it behave the same as the 32S2? David has created an interesting tool, which the people who are involved, agreeing with me or not, at first it's kind of like, what? That doesn't seem helpful. But once you use it, it's suddenly, what genius this guy has. You know, it's just amazing. You submit a program into the interface and it runs in parallel on a real ROM running in an emulator versus the current software, and the software detects if the results are different or not, and if so, captures it in a report. Like if you've done software and you've done software testing, is that gold or what? You know, and they're a small company, and it's things like that that let you project, you know, a bigger footprint than a one-guy shop kind of thing. Who else? Joe.
If you load a state file that's missing a section, like if it doesn't have the flags section in the state file, do your flags get reset or are they left alone?
I believe they are defaulted. Essentially what happens between state file loadings is a reset. So you're going to get default behavior. But there has been discussion, not finalized yet, of when you're moving into this model of multiple active state files, it quickly becomes, it's not clear to me what the right answer there. You know, it's easy to say one way, you know, keep them intact no matter what you do. You could argue for default states is what every program assumes you could argue for. So it's going to be a discussion that you'll be in. Who else? Yeah.
The state file thing looks like a really powerful thing. Is there any plans to make that available on the DM42?
On the DM42? So the DM42 supports state files. They work there now. The multiple ones isn't needed per se in the DM42 because it's more like the 41 where you have a multiple program address space and things can call each other by name. And so in a different sense, you can already accomplish that. So what the DM32 is trying to do is give you the same power of that, but in a different way that in some ways is more flexible. And what we've already started to see and what we're going to see is a lot of people, possibly including people in this room who, you know, do better calculators than the 32S2. I just do real calculators. You know, real men use RPL or stuff like that. You know, I wouldn't do it. But when you start throwing features like this at it, people are going, huh, interesting. Yeah, I think I want to try that. I really think I want to see how that, yeah, that's interesting. And it's still, the reason I've used it is because even though I, in some ways, still think in 41, you can just pick up a DM32 and like just write something in less time than it takes to think about it. It's because it's simple, it makes the writing process simple because there's fewer things to consider. But that, you know, that can be a limit, but it also can be an advantage to what you're doing. So, any other arms? Yes, sir.
I probably missed it, but how do you define a state again?
It's the contents of the calculator at any given moment. All of the variables, all of the program lines, all of the settings, all of the parameters that constitute at one time, grouped into one file. So I can just have my calculator with whatever I've got in it at this moment, save that file, save it over there.
It's an electronic write-all file.
It's like the equivalent of a 41 write-all.
So when I first started, I was just saying to people, do you remember a wall card, a set of wall cards? And people either go, yeah, I get it, or they go, wall, what wall? What do you know? Sorry, never mind. Exactly. Yep.
The reason I asked was that a state machine is
no relation. No relation to that. It's really, yeah, I can see where you're going. It's completely unrelated to that. Arguably not the best choice of names for that reason, because the people it applies to have that, you know, it's a common question. Yep. Anyone else? Let's eat.